content for the purpose of taking only we are putting the live stream. I think this is
Okay, okay,
support
sir.
content, right? There's just
So,
send a message, I mean, mail to support him regarding the date as well
yes,
as
sir.
the with the front end panel board,
Okay,
this
sir.
dashboard is not getting.
And I should get for the first 2 weeks, right? Right till now, I should get
Till now,
the
you will get
content of
first.
the first 2 weeks.
Exactly.
Okay, only first week. Okay.
Yeah.
I should have messaged it right now on the chat also of the meeting link.
Yeah. Sure.
Okay. Thank you, sir.
Welcome. And October 30th day is the day of first week submission for all. Please note down this number date. I hope you all know about it in the dashboard itself. Those who are not having this was will not get the dashboard content. Please remember that this October 30th is the last date for submitting your first week assignment. So to submit your video content, that content should be in the portal itself. You can upload your video here itself.
And sir, in the dashboard, like we have for other subjects, we would get a box like electronics lab, and in that there would be videos, right?
Yeah. Same in all the things in your electronics lab. Yeah, September 2024 electronics lab has some heading will be there, and under that week 1, week 2, the contents will be there.
Okay, so we have to go to the current courses section only, na, in the dashboard. We don't have to
Yeah.
look into different sections.
No, no, current session only. You have to submit your
Okay, sir.
content only in the current submission.
Okay, sir. Current courses section.
Yes, of course.
Yes, sir. Thank you, sir.
So how are we going to get the components?
And your voice is not audible. Can you please repeat again?
How are we
Hello.
going to get the components for electronic lab?
I mean, I hear you like, you mean about the video size?
No, no, the components to perform the experiment.
What are the components as required as like you are asking? I mean, I didn't hear you. What is your actual question? Is it my understanding is right? Is or are you asking about the what are the components that are required for the experiment one?
Yes, yes, yes.
Yeah.
Like and
How to execute it?
how to like from where to purchase it.
Okay. You didn't get that components? I mean, the previous ESTC lab itself, you got the two kits, right? One is the Adlam kit and another is component boxes.
Yeah, Adalem kit we got last time. Not the other one like ICs and all.
The lab itself you are given, right? If you purchase it, you may get it up. The lab itself. You didn't get?
Okay.
You didn't buy
Oh,
it?
no, actually, sir, we were from the first batch of ASTC. That time only Adalem kit was provided and the breadboard and that was provided,
The
not the
same day
ICs
itself,
and all.
in the same day itself, they are given another kit box with the what are the kind of components like breadboard, all the basic ICs, all the things are given to you.
Oh, no, sir, I didn't got that. I'll ask the support
You
team
didn't,
once.
yeah, recording this, you are just get it, otherwise you get the vendor where you can buy it also.
Okay.
So the component required for the first week experiment is about the inverter. We are to do the VTC characteristics, voltage transfer characteristics of the inverter. So here we are using inverter by this. I mean, by making your NAND gate as acting like an inverter. How do you do it? How to make it that NAND gate acting as an inverter?
To set one pin to high.
High. So make one pin to high, another pin is just variable input. Variable input is voltage should be varied by from 0 voltage to 5 voltage using your voltage regulator. That is where your POT, that is variable resistor is there. There is a notch will be above the variable resistor. You just unscrew it and clockwise or anti-clockwise, right? So based on that way of fixing a particular position, you get the desired voltage, some voltage. So please measure that particular voltage with your multimeter as well as even if you can use your NADLM kit also for measuring. Okay. So the expectation from the week one is you should be very aware about the, I mean, how neatly you have to make a circuit connection, and your cabling, that is what how your wiring, that wiring length should not be it should be measured, it should be measurable. So for example, you are connecting at node 1 and another node means that length should be perfectly connected, I mean measured, and please cut properly. And make your lead at the at least 3 mm size or 4 mm size, or something just that much size, not beyond that lamp. And just insert properly in your breadboard and check your connectivity using your multimeter connectivity testing. And finally you start do your experiment one, that is by varying your voltage and find measure the input voltage and what is your output voltage. Like this you have to keep on measuring from the starting point till the ending point and tablet each and every value, right? And if there is no deviation in your output measuring, yes, if you are keep on input varying and the output is not varying means, then you can scale up somewhat, you can take a long step. But if the voltage is suddenly changes from 5 voltage to something 2.3 something means, you just take very slow step. That is, don't give the same level of step input voltage. Like for example, I'm stepping input like 0 voltage, zero point 0.2 voltage, zero point 0.4 voltage. Like this, you are keeping the step of zero point 0.2 voltage differences means that time of sudden drastic thing means just reduce the step like 0.2 to 0.05, 0.04, like this, reduce the step and take more number of measures so that you get the smooth and go. Am I audible? Is it okay for you? So what I said is so far.
So in order to capture the voltage characteristics, wherever the signal changes rapidly, we have to take more measurements, more samples at that point. And yeah, and where the signal is somehow stable, we can move on with larger steps.
Exactly. So in simply in one word, I can say if the slope is zero, you just take long step. If the slope is not zero, take very narrow step. So in the forbidden region only, your slope is very large. So take very smaller differences and take measure all the voltages. Okay. And tablet
Sir,
and
I have a
using
doubt
the,
regarding
yeah,
in the circuit diagram, as the professor showed in the lecture, there is a capacity. We connect output of that tripod. Why is it necessary and what is its
the
use?
role of capacitor. It just block the unnecessary noises. The noise is nothing but, say for example, I'm just connect for example, I'm probing a particular point and I'm removing and again inserting at the same node. Okay, I'm just measuring the voltage at the same particular node. I'm removing and just again connecting, and there is no voltage changes at all. But what happens, you can see some glitches. That is a noise. Likewise, input side, you are giving some input, and because of external noises, that should not be I mean, that should not go change your characteristics. So we are removing this with the help of capacitor. I answered it.
Uh,
Sorry.
Capacitor, we use capacitor in the circuit there to somehow stable get the stable input. If input has some noise, it will be filtered out.
Yep.
So,
In simply, I can say it
as
is
I was
filtered out.
sir, as I was experimenting uh, the same and getting the input from my ADLAM kit. So if I turned on the repeated sweep on that option, if I turn it on, so I get a very fluctuating voltage as I read through a
What is
multimeter.
the time?
But
What time you are considered? Say there is some
sample
sampling
rate.
time. Yeah, sampling rate.
Uh, I was sampling at 100 milliseconds. But as
So
I turn it off, the repeated sweep, as I turn it
no, no,
off,
no. You just
it
keep a repeated sweep.
stabilizes.
You please keep repeated sweep. Please increase the sampling time to 100 instead of 100 millisecond. You increase to 110 second so that you can clearly visualize, because we can visualize in the seconds, not in milliseconds. Okay, our human
Uh,
eyes can able to visualize in seconds, right? So in the repeated sweep, if you keep in the sampling time as 10 seconds or 1 second, maybe 10 second is good to visualize it. You keep it at the 10 second.
So why was I getting such fluctuations if I read it through a multimeter? Was it not generating properly the signal?
It's generating the signal. You can't able to visualize in your oscilloscope clearly because your sampling time is very narrow down. Okay, you are putting it at 100 milliseconds, so it is keep on fluff. It is taking at the every 100 milliseconds of time. If you keep it at 10 seconds, then you can take enough time to take all the data.
Okay. But I was sampling, I was getting output a constant voltage, say 4 volt. But again, I was getting that much. So is it just a limitation of the kit, or
I mean, you are not getting 5 voltage, or what is your point? Is you mean that your output is keep on getting 4 point something, not 5 voltage? Am I right?
uh,
Or what
I
is
will
your
explain
question?
clearly. I will explain clearly. See, the DLAM kit has multiple pins. One of them being the 5 volt, constant 5 volt, and another one channel A and channel B. So, if I get 5 volts directly from that constant 5 volt pin, everything is fine. But if I try to get output from channel A and set channel A to output mode constant voltage. Say we set it to 4 volts, and then if I measure it through a multimeter, then
It won't give the 4
actually the
voltage.
voltage.
It will not
Yeah,
give the
yeah,
5
yeah.
voltage. If you measure, if you even if you set to some particular voltage with channels, the channel will not try to produce the exact output voltage. But if you want to get the exact 5 voltage, you may just take directly from that 5 volt pin, which is given along with that channel pin, that particular side of channel, or else you can take the value from PIO 0, 1, 2, 3, like this digital output will be there. But that is done by programming only. But you can take directly from 5 voltage. You want right now 5 voltage, right? So you can get it from your that 5 volt supply itself, or else 3.3 voltage itself. That is the exact point which is giving 5 voltage. The channel way you don't give the exact 5 voltage or take the, I mean, not provide such a sufficient voltage and current.
Okay, sir, got it.
But if you do it for measuring purpose, it can measure properly because the channel is used for both input as well as output. So try to use it for the inputting purpose, not taking as output purpose.
And sir, that tripod instrument, we can dial it many times, or is it limited to only some rotations? After that, it will fail.
No, no, it will. You can rotate out how much you want. Okay, but point is, it can give the output voltage from range from 0 voltage to the next voltage, or else there are three terminals. First terminal and third terminals you are connected with some particular potential like 5 voltage and ground voltage. Am I right? You are giving with a 5 to 0. Am I right? First and third pin.
Yeah, yeah, yeah. I'm
Okay,
getting the desired output.
from 0 to 5 only you will get it out. So the resistance is 1k, I think so. You hope you are having 1k only. So you can vary
Yeah,
your
yeah.
1k voltage
1K.
from this resistance, some 0 resistance to 1k only. Okay, so the if you want to get clear understanding, you can analyze like you just make some arrow mark and try to one screw up to particular 180 degree or 360 degree exactly one time. One time 360 degree you did what how much resistance you are, I mean how much voltage it is producing, or that means what is the resistance value. Like this we can able to measure it, and we can understand if I want to get this number of voltage means how much rotation I can do. Like this we can able to infer from that particular experimentation.
Yes, sir, I got it. But I was asking that changing its rotation multiple times, will it fail mechanically soon, or is it designed to sustain
Only thing
multiple
is that
rotations?
that screw will be comes out, that's it, and it turns to maximum resistance.
Okay, okay.
That's it, and
Thank
again you
you.
can unscrew back and you can use it again, no issue at all. You can use it. Yeah. Uh, any other questions?
Sir, what is the procedure to upload the videos? Like how to explain it and what kind of things we have to do to
So
submit the
this
assignment?
you have to present. I mean, we expecting the presentation should be very neat. In the present before presenting, your circuit must be very neat. So that is on your hand. So make your proper circuit connection, and when you start presenting, you explain about the connectivity checkups. Maybe you can take some more times, but the things which is not too required for us. So we may do editing like fast forwarding like that if you like, or else you can simply say one sample like this connection I'm just checking and it is perfectly connecting. Likewise, I have connected for everything. I will check with every other points also. Then you proceed with the input side. This is the input point and I'm giving this, I'm feeding this input. This is given by this pipe, like by snotching, by unscrewing and screwing the potentiometer. And this output voltage, I mean, this is the voltage is which I feeding to the one of the terminal of the NAND gate. Like this, you can explain it. Maximum you can do with 5 minutes, not more than that.
Yeah,
So you
okay,
have
sir.
to,
So,
and you have to explain much. These are the things which is already discussed in the video itself, which is given sample video by the professor itself. So what we expecting is what is your inference from that particular thing? What are the new things you have learned from there? That you can emphasize it in that 5 minutes of within that particular event slot of time.
yeah, okay,
Maybe
sir.
you can explain much more than the resultant value. How, what is the RTC, voltage transfer characteristic, how it is, what is your behavior, what is your inference from this, and why this particular goes like this. Like this, you can infer from that. Okay.
Yes, I got it. Directly we can just show the circuit and how explain how it's connected and then um,
Yeah.
tell about the input, output, and all kinds of such of things. Right,
Well,
sir?
exactly.
Yeah,
Exactly.
okay.
So
Okay.
last time I some of the students who have done like from the beginning, they are just inserting the elements and everything, and total time is takes to up to 10 minutes and all. And then they are fast forwarding these things again. This totally messy up our side. And necessary thing is that they mention it, like voltage transfer characteristics. These are the things which is inference from that experiment. They have to explain it, but they fail to explain the things. So like this, you should not do it. So you have to devise yourself what to be explained, what not to be explained.
Yes, I got it.
Sir, how do we upload videos? We have to provide a Google Drive link or just upload directly.
You have to upload in the portal only. In your portal, you can see the upload option. In every experiment, you can see that upload option. You have to upload there only.
Sir, in week two, there is a PDF file regarding which we are asked to do experiments. So, will we get any other explanation on how to do it, or is it all?
Yes, in the next live session, madam will come. The Vestra may come. She can explain about the analogs. Regarding the digital, if you have any doubt, you can ask. Is there no question? Means, shall we put this? Is there any question?
Sir, how do we identify different ICs and what are the standards as we are expected to do the experiment with IC 7000 and The one we got is from manufacturer HLF SN74LS. So, what are the how do we I mean name it, and how do we uh, get the meaning of what it says?
Okay. Your point is that how to, first of all, how to read the IC number, right?
Yes.
Yeah, 7454. These are the set of series are there in the market, and one is used for industrial military. I mean, one is for military purpose, and 74 is the commercial purpose. So that's why we are using the 74 series. And the LS stand for something about the scaling of. I think I don't remember that point, but it will be just like thinking about how many transistors will be there, like that. That is a representation in the form of LS. I think. Then 00 refers to a NAND gate IC number. So 00 refers to NAND gate, and 04 means NOT gate, and 32 OR gate, something. These are the gates are available in the market. If you want to get in depth of it, you can just write down the same thing data sheet. You just look for 74LS00 data sheet. If you look on the Google, you can download that particular PDF and you read that content. So specifically, like, it can show you like what is the limitation of this IC, like limitation in the sense like how, where and all this particular thing will properly work. What is the temperature it can properly work? What is the minimum temperature I can perform the same inverting operation, or similarly maximum temperature? Below the temperature it may not work. These are the conditions. These things we can able to understand from the data sheet only. So download the data sheet and understand it. Is it okay?
Is there globally organization or some authority who standardize that these namings, that what will
Okay.
the meaning of 7400 and other
Okay.
IC, and on,
So
on the
the company says, for example, Texas is giving like same thumb for LS00 means along with the TX they may mention. They want to mention about that company name also. Okay, similarly Intel also does the same thing. So the content will be same content only. There will be no variation at all. Maybe if they are specifically, for example, if you go ahead with a higher standard like a microprocessor, there only the changes may happen. It's not in these basic kits, like the how better quality, how best they are fabricating, like, I mean, not only the how depth of the doping effect they are doing. These things they can do. So you can study about the semiconductors, how the IC is manufacturing, how the semiconductor materials are packed tightly, how much level of intrinsic level they are in putting on, what are the external components they include. Like this you can study in detail later, but now for the time being you just understand what is that IC, what is the data sheet about. It says where and all I can able to apply it. Like this we can able to understand from the data sheet itself. It's a standard only.
So can I ask some questions?
Yeah, you can ask.
Sir, I joined late, but I don't understand where do I get the questions like for the experiments.
You are in the, I think you are registered in the portal, right? You have the access of looking at the portal, right?
Yeah, in my current courses there isn't any course of like the lab, electronics lab related.
Is it a course name like E1105 is there in your portal?
No, sir. It's basic digital systems and electrical and electronic circuits.
That is a theory course.
Yeah.
About that electronics lab like this, any course like that? If not,
Uh,
means please raise a ticket to the support team. You
okay, sir.
have, yeah, that's the only option.
And sir, I haven't received my ADLM kit also.
I mean, you have even purchased in during the ESTC course itself. After
Yeah,
ESTC,
sir.
I have, yeah.
Yeah,
It
they
should,
told that it would be shipped to our address. So I've given the
okay.
address, but it hasn't.
Well, you just okay. Anyhow, you just put a message in the chat bot and in the chat box. Otherwise, and also you please put the raise a mail also. Okay,
Okay,
I
sir.
just directly. I mean, personally, I can share these contents to them. Other than this, you can get support. But the way is support team only. Through support only, you have to get it all these things. I'm just supporting you. That's it. Indirectly. And just simply
Okay.
mention these are the things are which I received in the live session like this.
Okay.
Excuse me, sir.
Yeah.
So actually, my kit didn't include the 7400 IC. So I got it from outside from a hobby store. So it is fine, right?
Yeah, no problem. It's the same IC only. Wherever you get the same IC only.
Okay,
But
sir.
thing is, okay, anyhow, the last experiment of this electronics lab is you have to explain with the two number of some display the particular task using the two seven segment display, and for that you have to you may be having some two decoder IC for displaying, but you should not use two decoder for that. You have to use for only one. So make sure that one don't buy. I mean, obviously, you have one more decoder IC. Don't you have buy one more if you want for the a demonstration purpose? It's okay, but in the end of lab, you have to apply only one decoder.
Yes, sir. Actually, I got the decoders. I have the uh, amps also, op amp IC also.
That
The
is for
only
EEC.
was 7400. That's it.
Okay, you can get. That's. I think it'll be okay. You can buy it also. No issue at all. Okay. Any question related to the weak one solution? I mean, doubt you have means you can ask. Is there any question? Is there no question? Means we can wind up.
Hello.
Yeah, please.
Sir, I have some doubt regarding my course. Actually, in the previous term, I registered for digital systems and EEC along with the electronics lab. But in the course drop window, I dropped out of EEC course, and automatically my electronics lab would have been dropped. But actually I think there was some operational issue or anything. I was still receiving updates of live sessions, those assignments, reminder etc till the end of that term. And also recently I got grade I or mark 0, but actually I was not enrolled in the course. Even I didn't meet the criteria as I was not registered in the EEC. So, is there any issue,
No,
or
you just better you better you do one thing like you just raise a support doing that I have not enrolled. I just dropped the course is dropped. Now this term only I'm going to registering. So you better you don't send any related message. Please check that like you can just send a mail to them. And you
I
have
have
to
to message
mention
the
like
support team?
yes, I'm not registered. I just dropped down code, but still I'm getting something like high grade like that. I'm not registered. Please check that. That's it. Mention your mail ID clearly. That is
I
study
think
mail ID.
I think I did compose the reply after I got the grades, but they didn't responded. I have
Okay,
to
no,
mail it separately.
no, not separately. The same support team only. You just send clearly. If you want to compose it separately, you can send to the support team by composing into as a separate mail.
Okay, I
Okay,
will do it.
I think there'll be no more question. So if not, shall we wind up? Okay, fine. Thank you all. Uh, I understand. Oh, sorry. I sent to you, right? I'm sorry.
Sir, just last question.
Yeah, please.
Actually, what should be the value of the capacitance that we are going to use there in the input of second pin?
Yeah,
We
you
should
can
use
use.
anything which satisfies.
No, well, basically, 1 microfarad, I mean, 1 millifarad is given to you, right? You have 1 millifarad or 10 microfarad, 1 microfarad. Within this range is enough.
Okay, sir.
Okay, it's not I think that's measure the values is already given in the circuit itself, circuit diagram itself. You can use the same code or same value also. And that never actually for our exam experiment, it's not giving this much of hurdles. So when you're dealing with a high frequency common only, you have to too much of cautious like this. Is it fine?
Yes, sir.
Well, thank you.
Thank you, sir.